So for those who are on Zoom by the sound of my voice, we are getting started. Thank you for being here. I'm Doug Davenport, Executive Director of Prospect Silicon Valley. We have in the room a smattering of folks who have made it to Palo Alto at the office of Cooley. Cooley and a partner at Cooley, Gordon Ho, have been a big supporter of Prospect Silicon Valley for a long time, and we're really appreciative of them giving us this beautiful space. So thank you all for braving the traffic and coming today. So we're going to talk about decarbonized buildings and the path to market. We have a panel of experts that come from various parts of the discipline and from various kind of perspectives in their history. So that's going to be really fun. And then a set of startups that are working in some aspect of decarbonized buildings will be making some quick presentations. We're not going to do introductions. That would take far too long, but we're all glad that you're here. Those of you who are on Zoom did not get to meet people in person, so take that as a lesson. Next time, let's have you come and meet people, because we have good friends. See if I can get this to work. Does it work now? Yep. All righty. So this is the very complicated agenda. In general, what we're going to do here is I'm going to give you a quick introduction and kind of get us kind of primed for a discussion around decarbonized buildings. We're going to bring on a panel of Dave and Shannon and Aaron and Kelly from a really interesting, diverse set of organizations and backgrounds to talk about the challenges here, some of the opportunities. We'll have presentations by Bevel Solar, by FlexiDAO, and by InnoViews. I think InnoViews is actually presenting by Zoom, correct? So they're from, I can't remember, Taylor, Florida? Some really far away place. Houston. It's the Florida of the South. So yeah, from Houston. There we go. So they're going to be presenting by Zoom. So thank you all. And then we're going to have a Q&A, and startups, just so you know, part of what you're going to get is the benefit of the reaction of some extremely experienced people as to what they heard from you. But we're going to have an open discussion, and I'm going to move to the other side because apparently I have to be on camera. The one thing I really don't like to do. All right, is this better? Okay. We're just going to make this awkward. But you see, the whole thing is now I have to go back over here and change the slide. So thank you very much. Okay, so I'm going to come back over here for a second. You're going to run the slides for me, aren't you? Okay, very good. See, he told me he didn't want to run the slides. So all I had to do was stand in the wrong place for just a few minutes. And now he's got it done. Okay, so Prospect Silicon Valley, if you have not heard of us before, if this is your first time, you know, we really have kind of a three-part mission. One, to expand the conversation about innovative technology and how it can apply to problems we have today. So we tend to focus on how to expand the potential of a technology or a solution or an approach. We've gotten involved with autonomy and how that could really be a real transit solution. We've gotten involved in the early days, thanks to our friend here today, of decarbonizing buildings in a very difficult sector, the grocery sector. I'm sure we're going to hear a little bit about that today. And we've gotten involved with lots of other things. More recently, and we'll be announcing details of this soon, we're looking at how to expand mobility energy infrastructure in disadvantaged communities across the state of California. Right? How do you take a good solution that the free market is going to push and make it a wider and broader solution for lots of people? So that's number one. Number two, and welcome, come on in and sit down. Number two is to build peer networks. We are doing that today in one sense. You all have met at least 3-4 people you've never met before. And those of you who are on Zoom should be jealous. We build peer networks amongst people that have various kind of roles in the industry and various roles in the world, and we help them work together. That's one of the ways we can do number one. We also build peer networks of the people that are actually implementing the program. So we have what we call peer forums of actual responsible individuals in fleets, asset management, building management, et cetera, who are actively working to electrify their fleet, working to electrify their building stock. And we provide a starting point for them. So that's number two. I will mention that those peer forums are actually tremendously huge and a lot of fun. And we'll talk more about those soon. And number three is to really spark progress through collaboration. So when we do projects, we make efforts, we bring lots of people into the effort, right? So the decarbonization project we did long ago, and I'm looking at Aaron Daly, involved no less than 15, 18 different companies, including startups. A tremendous amount of collaboration goes into projects like that. And it's something that we really take pride in, that we can bring people together that would not normally work together and get something done. So that's what we do. You can change the slide. As a result, we've worked with over 100 cities mostly in the state of California. Some of those peer forums are now represented in 9 states. In the transit sector, but we've done just a tremendous amount of work with communities. We're actively helping them get things done. We've worked with a lot of startups, and we've helped to leverage now more than $600 million in investment. That's public investment, that's VC, that's project investment. We've been able to help kind of leverage that kind of money to make progress. So we're really excited about that. Let's go to the next thing. Okay, so we're going to talk about decarbonization. I'm going to stand up. So we're going to talk about decarbonization. So if you think you know what decarbonization is, you are likely wrong, because I don't think anybody has agreed on what decarbonization is other than minus carbon. Fair? So it all depends. And maybe the way you look at it, and maybe the way that your job intersects the challenge may take on different forms. So here's a simple picture of what that looks like. And I'm really hoping that the experts here they're nodding their heads, so I don't feel I don't feel scared. So one, when it comes to buildings, it's the components in the building, right? HVAC, water heating, ovens, Bunsen burners, anything that might be powered by gas could be powered by electricity, and that's one element of the problem. That's kind of where a lot of people stop, right? When they think about decarbonizing buildings. Well, it's also the sources of energy. It's the source of energy that you're receiving from your utility or from your power provider. It's what you have on site. It's the way that you interact with the grid that can make your facility zero carbon. It also could be the materials in the building itself. Where did the steel come from? Where did the concrete come from? What's on the walls? What's in the walls, right? There's a lot of potential there that is, I believe the term is embedded carbon. And there's also operational carbon. Aaron Daly, who's on our panel, is going to very much talk about operational carbon, I'm sure. Coolants are one big aspect there that a lot of people don't think of. As a matter of fact, the first time somebody told me coolants was a really important part of decarbonization, I went, oh, no. I have become a convert. So all those things are kind of part of this. Fourth is the function, right? So there is inherent carbon in how that building performs. It's how the people who occupy that building and when they occupy that building can influence the overall carbon sum. And this is, the dotted line as far out as you can go. How did the building get there? What happens in the building? How is that building managed, right? And the walkability, the wastes that are produced all have carbon influences that you could include in a picture of decarbonization. So what I want you all to hopefully agree here, and those that are on Zoom would agree, this is a much bigger problem than changing what's on the roof, right? It's a big deal. So that's what we're going to be talking about today. The other thing that's a challenge is the human challenge. Let's go to the next. And thanks for doing this, Taylor. So if you're an owner, you're going to be viewing a decarbonization from a cost and revenue standpoint. It's got to make dollars and cents, right? A building manager is going to be concerned with, do they know how to do it? if you change the components of the building, or you take a different material, you take on a different operational approach. Architects care about this. They're deeply committed to this, but there's all sorts of other functional and design issues, right, that you have to think about. And it may not, in some cases, it may not fully kind of align with what decarbonization is. You have to find a way to bring that in. You have to get them on the same page. Engineers, how many electrical engineers are feeling fully relaxed about decarbonizing every building in a region? It's a big problem, right? Big electrical capacity problems, lots of complexity there. And then tenants may not understand it. The value proposition to tenants has to be understood. Now, the good news is there are people that are doing this, right? We have experts today that are actively working in this space. We have, there's a lot of developers that are even today, building decarbonized buildings. So we know it can be done, but all the different players in the value chain for buildings have a different perspective on the building itself. And therefore the value proposition for decarbonization or any kind of solution has to be well understood amongst all of them. Because if one of those people texts back and said, I'm out, you're going to your next project, right? So this is a big deal too. So I wanted to bring those two topics up because, and thank you, Alex, for borrowing our cute idea shamelessly. We thought this was way better than a chart. With that, I just wanted to bring in those two ideas. Decarbonization is relative and has a lot of different layers. And the people involved in a decarbonization effort, either designing a new building or retrofitting, all have a very different perspective. And industry-wide, they're not all on the same page. Anybody that would like a download of this slide, we'll put it on. We'll put it on like GoFundMe or something. You can, no, just kidding. Glad you like it. We are a success, Carolyn. Okay, let's move on. So I think at this point, we're going to introduce our panel. Now, half of our panel, this is a hybrid event, so it just works out that half of our panel is here in the room and half of our panel is on Zoom. This is where all of my team gets really nervous and hope this works out. So I'm going to ask David and Aaron to come have a seat. I'm going to sit at the end. Oh, no, just leave that alone. I'm just going to sit at the end and have them have a seat wherever you like.
Right.
Sit over there.
I'm going down.
Give us a chance.
Nobody wants to next to you, Doug. What's up?
There we go. Well, this is the social distancing version of panelists now, right? This is how it's supposed to work. So, okay. So thank you for being here. Really appreciate both of you being here, and Shannon and Kelly. We're extremely grateful that you're here. You can see Kelly and Shannon up on the screen. Upper left, lower right. Wave hello, Shannon. Thank you. All right. So what we're going to do at first is I would just like you to introduce yourself, and we're going to go live and on screen, then live and on screen. So maybe starting with Aaron and then going to Shannon. Maybe introduce yourself. Tell us a little bit about yourself and why you care about decarbonization.
Great. Well, Doug and everyone, thanks for having me. It's a real pleasure to be here. I'm going to reverse the order of that set of questions and just say that where we're at as a society in terms of climate, the changing climate, and what needs to be done between today and 2030, and obviously thereafter. There is an enormous gap between what we're currently doing and what we need to do. And it's pretty clear that there is a path forward that is legitimate, that we can convince ourselves is possible, but it's going to take everything that we have to get it done. And so I'm here enthusiastically supporting the Prospect Silicon Valley group because this is exactly the work that needs to get done. We need to be promoting, ambitious action, and building decarbonization is a huge part of that. So I'm looking forward to the conversation. A little bit about me. I have been in the energy and climate space my whole career. I was consulting for utilities, kind of in my early career, doing energy efficiency program design and management. I ultimately went to work for Whole Foods Market and ran the energy management programs for Whole Foods Market for most of a decade. The last few years, I founded a not-for-profit organization called Ratio Institute, focused on sustainability and food retail. And ultimately, I've been in somewhat of a part-time energy efficiency program manager, part-time advisor to startups and consultant over the past little while here. Mm-hmm. And Doug and I got to know each other during my time at Whole Foods Market, where I was excited to collaborate with Prospect Silicon Valley on a net zero, the world's first, as far as we knew of it, net zero energy grocery store. And that was something I had been working up towards for a number of years, and something that my colleague Tristan Coffin was also very excited to lead on. So that's a project we remain proud of today. And so I look forward to sharing more.
And if anybody lives in San Francisco, goes to San Francisco, shop at the Whole Foods at Noe Valley and see what can be done. So that's really cool. Thank you. Shannon, wave hello and tell us about yourself and what excites you about decarbonization and why you're happy to be part of this conversation, please.
I'm Shannon Allison, and I am a principal at Alter Engineers in Oakland, California. Previously, I worked with David Kaneda up there. Hi, David, at Integral Group. So I've been doing mechanical and plumbing design with a focus in energy modeling and passive solutions pretty much my entire career. And at Alter, we do all electric designs, primarily in new construction and existing buildings, and with a focus on energy modeling throughout the whole design process, and mostly actually during the concept and SD level. And I think I'm most passionate about decarbonization because I just don't see why you would do anything else. It just doesn't make sense to not think like that, especially as far as passive solution goes, on the building level. And frankly, like right now, it's pretty easy to do all electric, at least in California. It used to be a little bit more difficult just because we had some pushback from the manufacturer side, and there's not that much pushback now. And actually on the contractor side as well, there's not a lot of pushback anymore. So it's kind of easy to do that. And so focusing with people like Dave now on like the grid and the electrical side, and how, if we were going to make everything electric, how the hell are we going to do that? Like so just working on that side of things now is really fun, because the building system side is kind of a no-brainer at this point.
Got it. And thank you, Shannon. So opposite of no-brainer is the electrical side. David Kaneda, introduce yourself.
Okay. Hi, everybody. I'm Dave Kaneda. I'm a principal with a firm called Ideas Consulting. And I've been working with Shannon for, geez, I don't know, 10, 15 years, something like that. But I'm an electrical engineer and an architect, actually, so I fight with myself. And my focus has been on green buildings, and then kind of things started out with green buildings, and then eventually went to net zero energy buildings, and then now the focus is kind of gradually evolving and shifting to decarbonization. So it's in my mind, we're on a path that's ultimately, it was about decarbonization, but kind of it was small steps at a time. I'm I'm extremely lucky because I'm an electrical engineer and it's gone to net zero energy. We did the first net zero energy commercial office in the country. And everything's gone to like electrical, right? It's the discussions of electrification. You know, for me, it's been important to, early on, we realized that, you know, I could physically only design so many buildings. And that's not going to solve the problem. So one of the things people like Shannon and myself and other people that I've worked with realize is that if you don't get out and talk about this stuff and teach other people to do it, then there's not going to be enough people that know how to do it to get things done. So I spend a fair amount of my time trying to do outreach and talk about what are the issues and convince people that, you know, we need to make all electric kitchens and you know, put batteries in and put PV in and things like that. So
If you haven't seen David's inductive stove Japanese wok lesson, where he starts it off laying a towel over his stove. I tried that at home. It did not go well. It's really cool. Anyway, go ahead.
Yeah, who knew that was going to go viral? So anyway, so that's what I do. That's what I'm passionate about. It's, as Shannon said, it's a ton of fun. So I'm lucky. I love what I do, and I get to feel like I'm really trying to make a difference and making a difference. And, you know, like, I guess most of us or all of us, I've got kids, and, you know, and there's a concern about when I'm long gone, what's their life going to be like?
Right. Great. Thank you. Kelly Cunningham. Wave hello.
Thanks for Hello. Thanks for including me remotely today. I'm based out of Sacramento. Would love to have been there in person, but wasn't able to pull it off for today's event, perhaps in the future. I work at Pacific Gas and Electric, and the energy providers play a significant role in the goals towards decarbonization. PG&E has released our climate strategy report and shares the goals to achieve significant emissions reductions by 2030, net zero greenhouse gas emissions by 2040, and climate positive by 2050. So within PG&E, I'm excited that the company is moving in this direction, and it's a really exciting time to also figure out how do you do that when you're a gas and electricity provider. So this is not a small task to have to undertake. My role within the company, though, on our codes and standards team is a little closer to what Aaron talked about in terms of energy efficiency programs. But the program that I'm the manager for is unique in that the state building codes advocacy lead. So I am aiming at, okay, so all these amazing things that like David and Shannon are working on to build the buildings of the future, what should be the code? What should be the baseline? How can we normalize decarbonization, and what is the best way to put together a package that becomes the minimum requirement statewide? So that's through the energy code, and now I'm venturing into Cal Green and the EV infrastructure requirements as well. And the role of our team is to propose measures to the Energy Commission and hope the Energy Commission embraces maximum efficiency that is right for all to be that baseline. Also, my role that I play is to assist cities, both as a liaison for PG&E and through my EE program that supports REACH codes that want to go beyond, that want to do more of what David and Shannon might be working on as the norm in their community. And ordinances and energy codes are really a hot topic right now, and have been for the last few years, as I'm sure many people on the call and in the room know. So I'm excited about trying to get towards our climate goals as a state and nation. And I hope that my role at PG&E can play one small part in getting us there through the exciting topic of codes and standards. Thank you.
Very good. All right. So we're all, and Kelly, I think we need to have you mute. Thanks. So we're all in now uncharted territory. We're going to do a panel that's both here and virtual. They are behind you, so you can't see them. Are you excited about this? Shannon and Kelly, you are here. If you have a point to make, do not use Zoom rules. Use human interaction rules and interrupt us. Okay, and I'm going to make sure that I'm monitoring you because I can see you both better than these two. Do you guys feel really like exposed at this point? Because this is super weird. Right?
This is great.
Yeah, this
Let's
is great.
do it.
But raise your hand. I'll make sure that we keep part of this conversation. This is crazy. Okay, so we're going to start with some challenges, right? So first let's talk a bit about engineering and project delivery. We're going to get into operating challenges. We're also going to get into kind of higher level challenges that comes with kind of mass decarbonization regionally as a starting point. Shannon says it's easy. David says it's hard. I think that she may have called you a liar. I'm not sure, Dave. No, but what's when you think about engineering and project delivery, I mean, what are the big complexities right now with decarbonizing buildings? And I just want to say, I think right now the majority of the activity or the majority of the work to be done is going to be retrofits. Is that fair? Or do you see this as a new buildings issue?
Retrofits are a bigger challenge in my mind.
Yeah, I would think so.
Yeah, I mean, I can add a little bit there. I think in places like the United States, we already have a very large building stock existing. Studies have been done that show it's far more efficient from a carbon point of view to renovate existing structures than it is to tear them down and build something new, regardless of how efficient that new building is. And so we're dealt the hand we've kind of given ourselves, in the sense that we've got a large portfolio of building stock that we need to figure out how to renovate effectively. And it's a huge challenge. You're given a greenfield site to build a new building with the technology available today. Thankfully, we have capable folks, unlike myself, but who can design and build those buildings. But I think the bigger challenge ultimately is going to be, how do we take the existing building stock and bring it up to not just to code, but ultimately to the level we need to get to that zero energy or zero carbon future.
So, and I appreciate that. Dave, Shannon, design issues when you look at this. What are some of the bigger design challenges that you see?
Shannon, you want to go first?
Yeah, I do. Thank you. For the existing building retrofits, it's the code actually. It's easier with the new buildings because, I mean, sorry, you can go the performance route pretty easily, but for the energy compliance, but for the retrofits, it mostly goes prescriptive, and yeah, it's just hard to really push the envelope, pun intended, on the retrofits.
We have our first building nerd joke. Okay. Yeah, but it's really true. And there's some realistic engineering capacity, or sorry, electrical capacity issues, right, Dave? As well as some physical space issues. Maybe you can go into stuff. And Kelly, please weigh in on that code comment.
Well, the energy code does have some limitations on its ability to compel really innovative ways to retrofit. In other words, to say you must do the following things. So the energy code itself does have some limitations in that. I would love it if local jurisdictions, for example, beyond just saying, okay, if you move to electrification, it's all good, that we could push that envelope a little further and really start to see envelope and other measures included in some of those retrofit compulsory ideas that are circulating. I also wanted to make a quick comment, though, on the new construction versus retrofit. Retrofit is the big opportunity that's harder to solve, but thinking about new construction and putting it on my PG&E hat right now, making sure that when new construction goes in, that if gas lines are extended to those buildings for small loads, we think as a society, what is that going to mean cost-wise as well? So all means all when it comes to electrification, if you're considering decarbonization when it's about the extension of the gas grid. So I hope that's a relevant comment, but I didn't want to get too far away from new construction
fine.
is settled without mentioning that. Thank you.
Yeah, really appreciate that. So Dave, engineering challenges, especially, since everything's going electric, it's all in your court.
I'm going to take back what I just said. Existing is more of a challenge from a kind of, energy use, and the building was set up to do one thing and now you're trying to make it do another thing. But new buildings are a challenge because of embodied carbon, right? And so the great thing about existing buildings is they're existing. You don't have to rebuild them. The walls are already there. The structure's already there. You don't have to put in new walls and structure, right? So all that embodied carbon is there. You don't have to respend it. New buildings, you do. So I think that's one thing. If you're just talking carbon, not operational energy and operational carbon,
Yep.
you've got to consider that also. So that's, I think, a challenge. And, I presented a green build a couple of weeks ago and I got stumped by somebody asked me, what's the embodied carbon of a battery? A lithium ion battery, right? I know now, but I didn't know back then. I can't quote the
There's
number.
like a
off the top
seventh
of
and
my
eighth
head.
and a ninth quadrant, so to speak. Yeah, that's a really tough one.
So there's two things about that question that were really interesting. The first is, I didn't know the answer, but there's an embodied carbon. The other thing is with a battery, like with PV, somebody asked, oh, what's the embodied carbon? And I'm like, oh, it's this many years. But then my follow-up to that is it generates electricity from the sun and it'll pay you back. And in the long run, it's much better. No question. Batteries, it's a different story. I could actually use a battery in a stupid way and emit more, cause more carbon emissions than not having the battery in the first place.
Right.
So there's two parts to that.
Right.
One
So there's
is
an
how you
operating aspect, which we'll get to in a
deploy,
second
right?
too.
The other thing I think that is worth considering also is EV, or vehicles are going electric and EVs are becoming a thing. So there's all kinds of implications on carbon and electricity in the grid and et cetera, that we got to think about.
So if you shift all of the energy, ostensibly, all of the energy that would normally be consumed, the carbon would be consumed from natural gas components in, let's say, just an office building, and you convert all that to electricity, how much load in the electrical side are you typically adding, just proportionally?
Hey, Shannon, you know that one?
Energy modeler, how much proportional energy
I don't
on the
know that
electrical
off the
side
top
do you
of my head.
add if you decarbonize a typical commercial building? Just give me a number.
That I'd have to, I mean, you're limited on it, on the amount that you can add. And that's where we get into it on the domestic hot water side with the tankless all electric, or the tankless electric water heaters are way too much kW typically. So then
And
you
there's the operative word.
so you can, there's definitely other options there, but
Right.
I don't think that there's
Got it.
a direct correlation just because you have so many options on the electrical
So the
side.
capacity of the building is limited and you
Absolutely.
could very easily blow that out of the water, right?
Yes, but there's two things. So people don't understand this about electricity. So there's two issues. One is how much energy are you using? And one is what's the maximum amount that you're using at any one time,
That's right.
right? So the big thing about the building's capacity and what's the incoming service and the size of the switchboard and all that, it's nothing to do with how much energy you're using. It's everything to do with at any one time, what's the maximum that it goes up to. Totally different thing.
Right.
Right, because it only has to go up once in a year or in the life of the building, and the circuit breaker will trip and power will go out. So, they call that demand charges, and it's like, measured in amps, and it's like, oh, it's 1,000 amps or 1,500 amps or whatever. But if you use a fraction of that, but you use it 24 hours a day. You can be using a ton of energy, which is a different thing. And so a lot of what Shannon and I are talking about is what's that maximum demand?
Right.
If you could kind of balance out that energy using batteries or something like that, you can keep the demand much lower and keep an existing service working.
Exactly.
And we're actually looking at that on some projects, is using batteries. So, you know, they can kick in a little bit of power when you're starting to overload your service.
Right. So if you go, you know, electric HVAC, electric water heating, you add EV charging, and you don't rethink how the building is managed, and you don't rethink how the building is operated, you can have a major problem.
You can,
Yeah,
but
it
if
can be a
you,
major expense to
That's right.
contend with.
but if you could manage that,
Right.
you know, the system conceivably has the capacity to add all that stuff and not miss a beat if you could manage when they happen.
Which is a good point at which to talk about operational aspects of decarbonization, right? One of them certainly is leveling out all the demands. Another is having on-site power, storage, other kinds of capacity that allow you to kind of shift all those demands around on the electrical side. Which, as you mentioned the other day, I just want to bring this in so you're aware of it. Space can be a huge issue when it comes to adding things like storage, especially if you're in urban environments, right? There's not a huge footprint to deal with to begin with. So there's a lot of, everything is very constrained there. But on the operating side now, if we start thinking about that, there is building management aspects, and there's other kinds of carbon. And maybe Aaron, I mean, if you can kind of kick off that discussion, you know, a little bit about building operations.
Yeah, you bet. Now, I think it is a good segue thinking about building design for electrification. You know, I think that issue of looking at peak demand, both at the building level and the switchgear level, you know, are you going to need to invest in an existing building to upgrade the panels, et cetera?
And even
a lot of additional costs associated with that. But, you know, then you look at adding electric vehicles to that. It's a whole nother set of investments, none of which was ever planned as part of, you know, how that building was conceived of in the beginning. The same is true also, you know, when you're looking at, you know, I've spent a lot of time working in the refrigeration space, and we've been working tirelessly to remove HFCs as refrigerants. And in the food retail space, we've been moving to CO2 as a refrigerant. It's a great refrigerant, but unfortunately, the downside is it has a higher peak demand. So now we've installed a newest system that has a higher peak demand. The coincidental peak, not just of that building, but of all grocery stores within a given area, once you've shifted from HFCs to CO2, is substantially higher. And just thinking about it from the electric utility perspective, you're not just dealing with the, you know, the panel at the building, but it trickles all the way back across the network. So I think, you know, we're going from a world where we look at a building as being kind of like, you know, a baby sitting in a high chair and they just tell you what they want, and you know, the parent gives it to them, a parent being the utility, to a world where the building is an active participant in the energy system. And whether it's electricity or something else, it's literally trading back and forth. And so the dynamics of that system on the building side and the dynamics on the utility side need to be synced up, and there needs to be data exchange, there needs to be information exchange, there needs to be economic exchange in order to allow that to transpire going forward.
Right. So there's this real day two type of issue here that maybe isn't often thought of. And that is, you know, you pay Shannon, you pay Dave for an excellent design, and it's delivered, and it is a zero carbon building on day one. Okay, day two, right? It's how you manage it. It's your supply chain. It's the materials. It's everything. You go from there.
So one aspect, obviously, the largest aspect of decarbonization of buildings is the energy that building is going to consume during its lifetime. Not for every building type, but for almost all building types. If you look at it on a global level, I think it's just under 40% of all carbon emissions, human carbon emissions, are from buildings. And about 3/4 of that is from the energy consumed to heat, cool, and do all the various other things that you do in a building. So there's still that 25% that, I know we'll get to talking about in terms of embodied carbon and other things. But 75% of that building carbon footprint is a very large piece of the pie. And so again, I think, what type of energy are you consuming? We talked about building electrification. If you're consuming electricity, where is that electricity coming from?
Right.
Not just what is the plant that it's coming from, but, if we're talking about renewables or other clean energy sources, they're not necessarily going to sit there and provide exactly the power that you want, when you want it, where you want it, et cetera.
Yep.
There is a whole network within the grid that has to provide that to you. And as a building operator, you're no longer in the place of just saying, just hand me power. Now it's your obligation to go out there and procure the power that you're looking for that meets your own, climate targets, climate goals. So that's part of it, working on the power side. If you are in the gas side, I think in the future it might be Pacific and electric, but we'll wait and see on that one.
At least with a small G.
But if you are on the gas side, there are other solutions to either liquid or gaseous fuels that can be used in buildings, and looking at that. And then I know, Doug, you and I have talked a lot about refrigerants. When people say refrigerants, because of the name, we think about refrigeration. You think about your home refrigerator, but the vast majority of refrigerants are being used now in air conditioning, and in the very near future in heat pumps. And that's a direct relationship to building electrification. And so refrigerants are the fastest growing source of carbon emissions that there is, from a relatively low point to potentially very meaningful carbon emission source. So knowing what your refrigerants are, knowing how much you have, what is the entrained carbon of the refrigerants that you have in your building, and then understanding your leak rates, what's leaking, where is it leaking, how's it leaking, et cetera, and being able to manage for that. So again, operational side of things, you're looking at quite a plethora of aspects that all have to come together.
Right.
And I haven't even gotten to talking about it, but all of the human side of it, do you have the trained people, or, do they understand all of the equipment that you have in place? Are there incentive structures all set up and aligned with the outcomes you're looking for?
And I want to pull in Kelly for a second, and I'm just gonna, let everybody know on Zoom and on my team, we're gonna take a few extra minutes on this panel to cover a couple of things. Turns out this is a complicated issue. Who knew, right? No, we knew. But we've so far been talking about one building. Okay, so, and it stays complicated right there. Now, if we're talking about, an entire district that's been zoned for commercial, and it starts to become mass decarbonized, and these shifts are happening and these demands are happening, it becomes an even bigger issue. Homes also, same thing. And Kelly, maybe, putting on your systems hat, so to speak, with PG&E, this becomes a very, thank you very much. You all saw it go on. Yeah. This becomes a really complicated matter. Maybe you could talk a little bit. I know you guys are working on a pilot that is addressing some of this kind of regional dynamic.
Yeah, and it focuses mostly on residential to start, but some of the way that the decarbonization strategies teams at PG&E and the gas strategy teams have been thinking about this is, what is it going to take to depart an entire community or region from the gas system? So we do have an application filed with the CPUC that went in September, and public comments are coming in, et cetera, proposing a whole community at the CSU Monterey area to depart from the grid and electrify everything. And what is it going to cost? And what are the customer concerns? And what's going to be the experience? And then what will be the great benefit? what will be the emissions reductions benefit, what will be the reduced cost to maintain the gas grid, which is a critical component, especially because not everyone's going to be able to pack up and leave at once. So those remaining on the system are going to need to cover the costs of the system. So this pilot is pretty exciting if we get to go forward with it. And it kind of matches our gas strategy managed transition plan, which is decreasing costs, reducing the carbon footprint, and also supporting hard to electrify customers because they are out there.
So maybe if it's possible for you to share in the Zoom chat a link to a description of that pilot or other information on that pilot, that would be great. We'd be happy to share it with everybody here too. That'd be cool.
Okay, I'll do that
Great,
at some
awesome.
point today, and so people can see it. Thank you.
So, okay, Dave, really quick.
I have to.
You have to do it. Have to do it. Okay, whatever it is, I want you to do it.
So, Shelley, Shannon and I spent what, like a year maybe, Shannon, doing a pro bono study on a, there's a lot of multifamily, I'm really salty, yeah. On a multifamily net zero energy project that we're trying to put in energy storage and resilience, a lot of EV charging. And one of the big things we ran into, and boy, if you could help me on this, I'd be hugely grateful, because I've been talking to other people that are experts in microgrids. And one of the things we run into is if you're trying to put batteries and PV and provide a microgrid for multifamily, I know how to do it technically, but from a rule standpoint, you know, other than putting like a little battery in each unit, which is crazy.
And cost prohibitive.
And cost prohibitive.
And possibly a safety issue.
And maybe a safety issue. You know, putting in
Just
a
helping you
central battery, which makes sense.
Yeah.
I don't know how to do it. I think it's illegal because you'd have to put it ahead of the PG&E meters. And then how does that even work, right? And so this is, you know, I know the state's trying to push residences into having batteries, and that becomes part of the solution. But for multifamily, which is a ton being designed right now in the Bay Area, I don't know how to solve that problem.
So what do you want Kelly to do?
Fix it for me.
Okay, Kelly.
Kelly.
Challenge accepted. Do you have any hope?
I don't know. I mean, I guess you can look at this from a couple different angles. When you say rules, you could be talking about CPUC rules, in which I am one peanut in the bowl.
It might be CPUC, right? It's like, how do can I connect a battery ahead of the meters, and then if power goes out, kind of serve the apartments. Yeah. And then how does the billing work if I'm going through PG&E meters? How do the meters know that the power's out and not to bill? Yeah.
So we're not asking you as a PG&E representative here, but as an expert, is there hope? Because we know you're involved with codes and standards. Is there hope for those kinds of ideas?
From the codes and standards angle, I think there is hope. I mean, with the 2022 Energy Code, we see a requirement prescriptively for non-residential buildings, certain building types to have PV and paired storage. So the code's moving in that direction. Right. So when you start to loop in all multifamily, which there is a little bit of a gap right now in terms of that's not necessarily required for all multifamily, but if you know the CPUC rules and the PG&E programs are going to have to come up with solutions, because absolutely the code is moving in that direction that when you build, you are likely to have PV requirements, therefore you are likely to have storage to have that building be set up for being a good grid citizen and demand management capacities. So this is going to have to be solved, because I do see it moving in that direction. How to solve the CPUC rules thing, I'm gonna slowly duck out of the picture for that one, I'm not sure, but we are also seeing a lot of rules change that have been hard and fast for a while on, say, like subsidies for building gas infrastructure. So there is movement at the CPUC that recognizes decarbonization is going to need a new rule set.
Right.
Cool.
So, and when you combine, this is not a joke, when you combine a major technical challenge with an eventual change in rules, what do you have? Startups, a business opportunity, right? So, I mean, there's markets that are going to come out of decarbonization that maybe aren't all completely apparent. You know, there's trouble today, and I'm kind of coming to our last topic before we move to our startup presentations. You know, the net financial add on going carbon free on a new building can still be somewhat significant. I was talking to a major developer who will remain nameless on that works in a major scientific sector that told me that some of their decarbonization or decarbonized buildings were running close to $10 a square foot more to deliver them. That's a lot of money. But they can do it because the opportunity is there, because the premium that people are demanding for high quality spaces is still relatively high even today. So there's still going to be a cost cap. There's still going to be a realistic cap on what you can really spend on a building. You have to make choices. Some innovation opportunities that you might be interested in sharing, right? Such as when we talked about building management and being able to manage demand across a building and manage output within an envelope, right? You would consider that to be a major opportunity for future buildings?
Is that a question?
Go ahead.
I think there was a question mark on the end of it. So yes, you'd agree that would be a big one. We already kind of covered that one, right?
The software piece.
Right. So the software and the controls piece is a huge one. Project delivery is a huge one, right?
Yeah.
We recently had a panel at Verge where we talked about the fact that for most buildings, we're talking about small buildings, which is only about 95% of the buildings we'd be working in. You don't need a ton of new technology. What you need are faster, cheaper, smarter ways to do retrofits and smarter ways to get these things done. So kind of packaged and prepackaged and quick ways of making these changes. That's a real opportunity for decarbonization as well, right? Are you seeing some of that?
Oh, absolutely. Yeah.
Right.
Modular. We were just talking about that before the meeting started.
Don't spoil it.
Modular design and things like that.
Yeah.
Is becoming a thing. Pre-manufactured pieces.
Other innovation opportunities that we see here that you wanted to bring up?
I don't know if I'd consider it an innovation, but I think one of the challenges that we're facing that ultimately there is a lot of effort to address is looking at buildings rather than looking at buildings on a first cost basis, looking at them on a life cycle basis. So, that's like, well, are we building this building to last 100 years? And in which case, let's think about it through that lens, or do we really only have a 10-year window on what this building is really going to be there for, or something in between? So, that's one part of it. And the other part of it is, connecting the dots between the designer, the contractors, the building owner, whoever's
Right.
leasing and operate and occupying the building, and connecting basically the incentives of those various parties such that you can have a building that is optimized. Because
Right.
a big part of the issue is just that folks don't necessarily feel the pain of the operator. So, I, as a building operator, historically took on whatever I was given and made the best of it that I could.
Right.
But if I had been able to reach back in time and make a few very small changes, potentially, it could have improved my operational opportunities considerably. So I think that there's a lot of opportunity for innovation in that space.
Okay, we've talked a lot. We're gonna stop here. I want to thank you all for being part of this panel, but you're going to stick around because we're going to have you part of a Q&A discussion. So I'm going to hand my mic over to Taylor, and Taylor, you're going to kind of MC the we have 3 startup presentations, I think, starting with Beam.
With Bevel Solar. So Peter Gross, come on up here. And Neil.
Stay right there, maybe. Is it okay if they stay here, or you want to bring them back up?
I think, no, let's have them sit down.
Have a seat. We'll bring you back.
You guys get to have a break now. All right, next we've got Paul Breslow from Flexidow.
Thanks. Thanks, Doug, for having me here. It's great to be live in person with some people and also hybrid if the folks are still on. So they're still on. Great, great. So thanks. Let's see, first slide here. So how many people here are familiar with the concept of carbon-free energy, 24/7 carbon-free energy? Is anybody familiar with the concept? Okay, one or two people. So yeah, so we only have 5 minutes, so I'll just do it very briefly, but obviously we can't manage what we can't measure. And many people are familiar with renewable energy and the idea, as David was mentioning earlier, of this concept of power and time. And the energy that we're buying, often we're buying renewable energy credits over the course of months and years, and then trying to say that we are being decarbonized, we're trying to be emission free. It's not necessarily 100% the case, because the building that you are powering is using power at midnight, and that's coming from coal or gas or some other type of facility. So what FlexiDAO does is try to help companies to be able to measure that and be able to manage towards that. So thanks, Taylor. Next slide. So obviously a lot of organizations are facing ESG challenges. There's both the challenge here with the unknown, the standards are changing. I think there was a great conversation earlier about standards and protocols. And personally, I just joined FlexiDAO recently after spending 7 years at one of the largest energy companies in the world, looking for the best startups. And part of the reason why I joined FlexiDAO is that they are actively working with the standards organizations like GHG Protocol and others to help to develop them so that we can transition from buying renewables on a patchwork basis towards having a truly decarbonized and green grid. And so there's an opportunity to show leadership, but also an opportunity to reduce the risks and the cost by being able to buy and procure in a way that is both economical and lower carbon. So what does that mean? Well, the challenge, as I expressed, is there is an opportunity to buy wind and to buy solar and to do on-site generation. But if you do all that and you're familiar with the way that it looks, your amount of production is going up and down, and your demand curve may be very consistent or doesn't match that. So then what happens in that situation? So one of the ways we were able to do that and to think about that is to start to measure it. And if you're not familiar, these charts down at the bottom, these kind of fingerprint charts are really interesting because they show you how you can look at the chart on an hourly basis across 365 days. And so if you start to buy green energy, maybe with solar, you're reducing emissions, but not until you're really fully measuring it and managing it and thinking about your procurement and then getting your procurement, your suppliers to be able to match your demand, are you actually eliminating emissions? And that's what 24/7 carbon-free energy is. And so we've raised money now from Google, from Microsoft, some of our partners and investors, and we have customers, Iron Mountain, which is another large data center operator. And if you're not familiar, we've started to have some cities and even the federal government start to say that they are going to start to procure on a 24/7 carbon-free energy basis soon. And we have some other customers and partners. So what do? We're tracking it and then helping customers to manage towards that. Taylor, thanks again for changing it. And one of the things I think is really important, and part of the reason why I joined, is we're really focused on a thought leadership. A lot of what we do is educating people on the concepts and where things are going. It is inevitable that we need to get to decarbonization and to have green power. But what does that mean as individuals, as we're trying to help our organizations go through that process? So obviously, I'm not going to go through everything on this slide, but it's an education process, the beginning, and then being able to start with the initial baselining, and then to move through the process of helping with the strategy and the procurement. So obviously, we're looking at the energy credits, we're looking at the production side, the consumption side, and then the CO2 side, pulling all that data together, enabling people to visualize it, and then putting some analytics on, enable people to enact on it. Okay, and anyway, I think we have to wrap up here. But obviously, we've worked with a number of large customers, and happy to chat with anybody else here or afterwards. Thanks.
All right, we have one more online. I want to make sure I get him set up here. So let us know if you've got your mic going, and then we'll have you introduce yourself.
Hi, everyone. Can you hear me?
All right, loud and clear. I'll let you share screen now.
All right, perfect.
Okay, looks good.
Perfect. All right. Well, hello, everyone. My name is Anas Al-Qassas. I'm the founder and CEO of Innoviews, joining you from remotely from Houston. Appreciate the opportunity. Innoviews is the sole provider of renewable glass retrofit platforms. So we enable the decarbonization of buildings, and we make them more energy efficient and sustainable by retrofitting their facades with the latest energy saving smart window innovations without replacement. Let me give you a quick overview of Innoviews first. The company was founded in 2017, headquartered in Houston. Our customers, partners, and early adopters include Fortune 500 companies, some of the leaders in the commercial real estate space, and an alliance of over 140 energy utilities. Our technology has been implemented in buildings across the US, and we've been backed by some of the great investors, including Saint-Gobain, one of the world's leading building products and materials companies. Won a number of startup competitions and awards nationally and internationally, and got featured by Bill Gates Breakthrough Energy in their climate action playbook. If you look at this thermal image in New York, I mean, most of you probably know that buildings are the largest energy consuming and carbon emitting sector, but you might not know that a building component like the windows are responsible for up to 40% of the energy loss in buildings. And that's because about 70% of all buildings today still have energy inefficient windows, single pane windows in most cases. And that's why many cities that are committed to 80% CO2 reduction targets by 2050 or earlier are increasingly requiring existing buildings to meet stringent emissions targets. And many are offering significant incentives to encourage building owners to do energy retrofits, including window retrofits. Now, the problem is that upgrading building facades and windows requires replacing all or parts of the systems that are already there. And this is a very complex and labor-intensive process. As you can see here, it's a very, very disruptive process to the operations and businesses. So it really leads to really unrealistic payback periods and negative ROIs in most cases. So to address these key barriers, we've developed a solution, a window upgrade solution that basically offers the same benefits of a full window replacement project, but at a fraction of the cost and time without disruption, basically offering up to 10 times faster payback periods. Just a quick overview of how the system works. Basically, we invented a system that uses the existing windows as part of the solution instead of throwing them away. So it requires 70% fewer materials than a full window replacement. It also eliminates the cost for demolition and disposal of the existing windows. 2, it is prefabricated offsite for quick and easy installation, which cuts installation costs by up to 80%. And 3, it's an overglazed system that does not require removing, replacing, drilling, or altering anything to be installed. So no disruption or loss of income from the retrofit. Here's a quick illustration video to show you how the system works. So the first component is a support spacer frame that gets attached directly on the glass from outside or inside using a pre-applied structural glazing material. We apply a little bit of a pressure to activate that material. And then the second component is a prefabricated unitized glazing panel. This glazing panel gets mounted on the support spacer frame, gets locked into position using a small 3-axis movement without barrier, without any fasteners. And then at the end, we apply a special perimeter sealant to the tolerance gap at the perimeter that is set by 3D printed head guiding tools. So you can see here what's existing, if it's single pane or double pane, and there's the framing, and that's what's added on top. So here's a quick overview of before and after. In a few words, what we're doing basically is we're turning single pane windows or low performing double pane windows into high performing multi-pane systems, providing up to 10 times higher performance depending on the performance of the newly added glass. We got several patents issued on this technology and the retrofit method, and because the novelty here is that we made it technically possible.
Just want to let you know you have about
way.
just a few seconds left, about 30 seconds left.
Okay, so let me installation can be done from the exterior using existing swing stage platforms. No need for custom installation scaffolds. Can help rebrand the building or preserve the appearance of the building, depending on what the owner is looking to achieve. As an example, all systems provide more like a platform that enables the integration of some of the advanced glazing technologies like transparent PV, smart glass. And lastly, here are just a few examples of case studies we've done on buildings in New York. You can see the range of payback here, difference between our solution versus a full window replacement. That's all. Thank you so much.
All right, thank you very much. I'm gonna hand the mic back to Doug.
I really want to sincerely thank our panel, both from afar and here. I want to thank our startups for coming and sharing exciting stuff. And Anas, thank you for joining us from Houston. Really appreciate all of you that made the trip here. We actually at peak, I think we had over 35, close to 40 people in attendance. It doesn't feel like it in this room, but there was quite a few people online too. So really appreciate everybody's contributions. This is clearly a really, number one, a really dynamic problem to solve. It's a really exciting market. It's a really exciting time. So we're going to be tracking this. I will tell you that we talked about peer forums. We're going to be launching a peer forum for building decarbonization. It's going to be focused very differently from the one that we were doing working with fleet groups, where there's a single buyer that's representing an organization. Here it's going to be about the project teams. And these are team efforts, and it's going to be a really interesting forum to bring forward. So we're excited about this, and we're going to be spending a lot more time on building decarbonization moving forward too. So with that, thank you all. Grab a little food in the back if you'd like. There's still a little bit, and we'll stick around and get to know each other here. And those of you online, you're missing out, but we really appreciate you could attend.